Hi, this is Mrs. May. Today we're going to be looking at solving systems of equations using the elimination method. So far what we've done in the past is we started out with graphing to find a solution, and then we moved on to substitution to find the solution for a system of equations, and today we're going to be looking at using the elimination method. So we're starting out, we have these these two equations right here. And what we're going to be doing is converting them so that they are workable so that we can eliminate one of the variables. It doesn't matter which variable you eliminate, but you need to eliminate at least one variable in order to solve for the other. So as we look at these equations today, you're going to have to determine which one you feel is the best one for elimination as far as the variable is concerned. And so we have a couple of examples for you. You'll probably want to pause this video several times to take some good accurate notes. So we started out with these two equations, and I'm just going to quick put up a screen here so that I can show you what happened. We have these first two equations. They have nothing in common. We have a 6x, negative 2x, can't eliminate either one at this point. We've got a negative 2y and a positive 3y. What needs to happen is you need to find a number that works well together so that you can eliminate one equation or the other, or one variable or the other, not the equation, but the variable. So we're going to be looking at which one we can do. So what I'm going to do is actually multiply both of these to this. And how you do that is you look at the distributive property in a little bit different way because you're distributing across an entire equation. So what I did here is I multiplied by 3. That 3 came from here. And the reason I did that was because I wanted to get this y eliminated. So what I did is I multiplied 3 times 16x gives me 18x. Negative 2y times 3 is negative 6y. 1 times 3 is 3. Notice again, it had to go across all of the entire equation. You're multiplying by 3 using the distributive property. This second equation, I multiplied by 2. 2 times a negative 2x is negative 4x. Positive 3y times 2 is 6y, and a negative 5 times 2 is negative 10. What this has done is if you look here, we have a negative 6y and a positive 6y. Those can now be what's called eliminated or taken out of the equation. So I'm going to erase what we've done here. And again, you'll want to probably pause your video to take some good notes. Once I have this in a situation where now this can be eliminated when I add these equations together. I have 18x plus a negative 4x is 14x is equal to negative 7. 3 plus negative 10 is negative 7. Okay, so now what I'm going to do is divide out this 14 so that I can get x by itself. And x is equal to negative 1/2. Now that I know what x is equal to, I can take this solution and I can put that back into one of the equations to solve for y. So I'm just going to, at the top here, put, okay, x is equal to negative 1/2. And I'm going to subtract 2y equal to 1 here. So what this has left me with is 6 times negative 1/2, and I'm going to move this equation down here, is negative 3 minus 2y equal to 1. When I move 3 to the other side, I end up with negative 2y is equal to 4y. When I divide by that negative 2 is equal to, it's very sloppy writing, but what I end up with, y is equal to negative 2. So I've got these two coordinate numbers, if you think of x as y and y as negative 1, negative 2. Now I can take those solutions and I can put those back into that second equation and make sure it works. You always want to make sure that you put that solution back into the other equation, because we know it's going to work for the one because you just solved it using that. So we have to always make sure that we take this back into the other equation. So I'm going to put negative 2 my x was negative 1/2 plus 3 times y, and we said y was negative 2, is equal to negative 5. Negative 2 times negative 1/2 is equal to 1 plus 3, plus 3 times 2, which is equal, or 3 times a negative 2, which is equal to a negative 6. So looking at this, we end up with 1 plus negative 6 is equal to negative 5. Is that a true statement? Yes, it is. So your solution is x is equal to negative 1/2 and negative 2. Y is equal to negative 2. So you have your solution. Here's a second example, and you don't have to always multiply both of them. This second example, I want to show you how you could just simply multiply one of them. So as we're looking here, we see a 5 and a 10. That looks really nice. We can do something with that. But this 5 has to, or this equation here, this is a positive 10y here. So we'll want to make sure that we get this part into a negative 10y. So to do that, we're going to have to multiply by a negative 2 for this equation. This is going to give you negative 2 times 2x, which is a negative 4x. When you do negative 2 times that positive 5y, that's going to give you that negative 10y, which is what we wanted to, in order to do some elimination, is equal to a negative 2 times 3. So again, we've got this negative 2 times 2x gives you a negative 4x. Your positive 5y times that negative 2 gives you a negative 10y, and 3 times negative 2 gives you that negative 6. So now we can rewrite this other equation underneath it, and we remember that we're adding these. Didn't have to do anything to the second equation, just left it as it is. This leaves us with negative 4x minus 3, or plus 3x, which is a negative 1x. This is now eliminated. And we have that, when you add those together, you get negative 9. We don't like that negative in front of that x, so you're going to want to multiply by negative 1 on both sides. That gives us x is equal to a positive 9. So again, we have part of the solution, but we now need to figure out the rest of the solution. So I'm going to erase some of this because we don't need all of this. And again, hopefully you paused, and if not, you'll need to rewind to get back to where we were at. I'm going to substitute a 9 into this equation. So we've got 2 for x, which is 9, plus 5 times y is equal to 3. So we've got 2 times 9, which is 18, plus 5 times y equal to 3. Subtracting the 18 and moving it to the other side of the equation, we end up with 5y is equal to negative 15. And we've got to divide out that 5, y is equal to negative 3. So we've got the solution here. X is equal to 9, y is equal to negative 3, but you still need to put it into the second equation to make sure that it works. So we've got 3, x is equal to 9, y is equal to negative 3. Putting it into this equation here, making sure that it works. 3 times 9 is 27. 10 times negative 3 is negative 30. Is 27 plus negative 30 equal to 3? Yes, it does, and so it checks out. So always make sure you put it into that second equation. Example 3. Notice that the equal signs, these are little messed up equations. I did that purposely so that you're forced to make some changes. In this case, what I would do is you can see that the 3x minus 7y is together. So I would move this x to this side of the equation. So I'm going to write this up here. We've got 3x minus 7y is equal to 5. When we move x to the other side of the equation, remember you're subtracting 5x. So this becomes a negative 5x. This was a positive 9y, leaving that positive 5 on the side of the equation. So what we've done is we've taken and moved these equations around so that they line up and they look a lot nicer than they did to begin with. So again, you have to make a decision. Do you want to eliminate the x? Do you want to eliminate the y? Neither one is matching up at this point, so we're going to have to do some multiplying, and it looks like we're going to have to multiply both of them. So just to keep things simple, I'm going to multiply to get rid of the y's. And so the greatest number that they have in common is, or the smallest number that they have in common is going to be 63. So that means I need to multiply this equation by 9 and this equation by 7. So when I do that, I end up with, and hopefully I have enough room here, 9 times 3x is 27x. 9 times a negative 7y is a negative 63y. Negative 63y. And 9 times 5 is 45. All right, multiplying the second equation, we've got 7 times negative 5x is negative 35x. 7 times positive 9y is positive 63y. And 7 times 5 is 35. Again, we're adding these equations together. So we've got a 27x plus a negative 35x is going to be negative 8x. This has now been eliminated. We've got 45 plus 35, which is 80. Divide out that negative 8. X is equal to negative 10. Now again, you can take these back into the original equations. They're a little bit smaller numbers, which is nicer. So we've got 3 times negative 10 minus 7y is equal to 5. That's going to give you a negative 30. When you add 30 to both sides, I'm going to move this equation down here to negative 7y is equal to 35. Divide out the negative 7. Y is equal to negative 5. So we've got y is equal to negative 5. And again, you might want to pause because I'm going to erase. Substituting in these numbers to make sure they work in that second equation gives us 9 times negative 10 for x, 5 times negative 5 plus 5. Oh, I'm sorry, excuse me, I wrote that wrong. Time out. I forgot the equation was moved around. We've got 9 times negative 5 is equal to 5 times x, which is negative 10 plus 5. Sorry about that. Eraser. We've got negative 45 equal to negative 50 plus 5. Is that a true statement? Yes, it is. So make sure that you're taking a few minutes to write all of these steps down. And then for tomorrow, when you come in, I want you to practice this problem. Please make a note that our x's are here, our y's are here. And so you're going to have to do some flip-flopping around of that equation to make sure that you can properly do some elimination. Good luck, and we'll talk about this problem tomorrow.